Good morning, and thank you, Jeff. High praise from the man himself. I've been in this space for a long time. I'm a working data scientist. I am also lucky enough to have become an advisor to many successful companies right as they were starting out. And I also have been and continue to be a conference chair for many AI conferences. So long story short, I get to hang out with some of the best and brightest in the AI space. So ChatGPT was released almost a year ago, but actually there were several other large language models before then. And in this talk, I'll try to kind of crystallize some of the best practices and trends in the LLM space. So the word frontier model or foundation model is used for many sorts of models, but at a high level, I think the most familiar ones are these text in, text out, kind of like the ChatGPT model. But if you look at this diagram, it looks like a simple NLP library. But of course, we know that ChatGPT and BARD and these large language models have many interesting properties. A couple are worth pointing out. One is they are very versatile, so they can do more than one thing, unlike an NLP library, right? So they can summarize, they can write, they can even write code. And they're also highly instructable, so you can give them hints using the prompt, right? So you don't have to just rely on the training data in order for them to get anything done. And within a year, the usage has been tremendous, right? So this is just one example in the space of writing code. So the typical stereotype is that only novice programmers or beginners use AI tools to write code. But this chart from Stack Overflow in their recent survey of thousands of developers shows that actually developers of all experience levels use these tools. And in fact, Satya Nadella called out specifically code writing tools in his latest letter to shareholders. He pointed out several really high impact use cases for AI code writing tools. And in the short time, the impact of these models has been profound, right? So this is the first formal academic study out of Stanford of the impact of LLMs. This is a real-world study of over 5,000 customer support agents at a Fortune 500 company. So 14% increase in productivity is enough to really get the attention of any executive. A couple of other things worth highlighting. One is that actually the low performers benefit the most from the LLMs, according to this study. And then most importantly for someone in the customer support space, these tools seem to have helped with employee retention, which is a huge problem in customer support. So I've seen many tech trends, but this feels a lot different to me. So in less than a year, we have a set of tools originating mostly from the West Coast of the US, now impacting the work of programmers and knowledge workers across the world. All right. So let me describe the typical user journey for these tools. So for place to start is using the commercial large language models like ChatGPT, BARD, and so on and so forth. So the providers here are OpenAI, Google, and Anthropic. But many people, after playing around with the commercial LLMs, turn to the open source large language models. And at this point, we have a few major suppliers. I'll call out a couple. The first one is Meta. They have a family of large language models called Llama. And then there's another startup out of France, which is fairly new. They have a couple of really good-looking large language models called Mistral. So why do people turn to open source LLMs? Well, at a high level, obviously, you might immediately think, I have more control if I have control of the model itself. It could potentially be cheaper if I control the model. I'll address accuracy in a second. The other main promise is that the open source models turn out to be somewhat smaller than the commercial models. And so if the models are smaller, presumably then they can be more efficient and faster. And in the LLM space, I know you've used ChatGPT and some of these tools. You know, response time is quite important, right? So you don't wanna, you want responsive models. So the promise here is maybe if I can control the models and they're smaller, I can get faster applications. But there's a catch, right? So it turns out that there's a lot of engineering and IP that goes into deploying these models. And the reason is, while I said that these models are smaller, they're actually still gigantic models relative to the traditional machine learning models that we've come to use, right? So when you look at the so-called small models from Meta and Mistral, you're still talking about models with 3 billion or 7 billion parameters. And most teams just don't have the expertise to deploy these models. So the good news is that there are many, many open source model providers, right? So I personally use Anyscale. I'm an advisor, full disclosure. But I find it to be very fast and stable. And let's see, and yeah, so it's also very easy to start with. You just swipe a credit card and you're good to go, right? So, and yeah. So the other thing about Anyscale is they have private endpoints, so you can run these models on your own private cloud if you want to, right? So you can take the entire infrastructure, all of that IP that Anyscale has put into deploying these models efficiently, run it on your own cloud. All right, so I talked about open source LLMs. And these base general purpose LLMs are phenomenal, right? So ChatGPT, Bard, Meta Llama, and so on and so forth. But they're general purpose, right? So, but what if you can take some of these models and tune them for your own specific task or application, right? So that's the promise of custom LLMs. And there are many driving forces, right? So at a high level, if you control the model, presumably you'll have more control over privacy, security, and your intellectual property. I mentioned if you control the model, maybe you can deploy it more efficiently and cheaply. But the promise that I hinted at earlier was if I control the model and I can customize it, maybe I can come up with the best of both worlds, a more accurate model that's smaller and faster, right? So it's unclear. But let me try to convince you why that might be the case. The first thing is you're probably going to customize one of these open source models. And these open source models, I think not a lot of people have been paying attention to them, but they've actually gotten to be quite good, right? So here's a chart which shows you that Llama, the largest Llama model, is already as good as GPT-4 on factuality for summarization, right? So, and more importantly, Llama 70 billion is actually much better than GPT 3.5, which, you know, less than a year ago was considered the best large language model. So these open source models in a short time frame have gotten to be quite good. All right, so what's the promise of fine tuning? So here's a real world example from Anyscale. For a very specific task where you take a natural language sentence and turn that into an SQL query, right? So baseline model, untuned Llama 7 billion, sucks, right? So 3% accuracy. With some fine tuning, boom, 86% accurate, much better than GPT-4. And since this is a 7 billion parameter model, it's much faster and much cheaper. Right? So this is what fine-tuning can do, as long as your task is well-defined and narrow. So how does fine-tuning work? So fine-tuning works very similar to what you would do for supervised machine learning, right? So in supervised machine learning, step number 1, gather labeled examples. So same thing here. But the labeled examples are, here's a prompt, here's my desired output. Prompt, desired output. So that you need to gather enough of those. And I don't have a rule of thumb, but I would say a couple of thousand of examples is quite good. And I personally have fine-tuned many accurate models with only about 500 to 600 examples. All right, so collect labeled examples, then you select a fine-tuning technique, just like machine learning, right? So here's labeled data, and then I have to select the algorithm. And then I actually fine-tune, and then I go through the process of evaluating whether my fine-tuning worked well, and then I deploy. So something that most ML teams are familiar with, this workflow. So, but fine-tuning, just like machine learning models, right? So machine learning models, you have so many options. Fine-tuning, there's so many options for what fine-tuning technique to use, right? So very similar to machine learning. But let's take one example, and this applies to, what I'm about to say applies to any kind of fine-tuning technique that you choose, right? So LoRa, which is a very popular technique because it's very efficient and fast. So with any fine-tuning technique, there's certain parameters and knobs that you have to tune, just like in machine learning, right? So in LoRa has LoRa-specific knobs you have to tune. So tuning knobs in a machine learning model means you have to be able to run experiments in order to arrive at the right, most optimal configuration settings. So running those experiments at scale means you have to have access to a lot of either expertise or distributed computing, right? And truth be told, not many teams today can do this on their own. All right, good news. You have services that make this dead simple. So again, I personally use the service from Anyscale, and all I have to do these days is focus on the labeled data. So the workflow is basically, I spend all my time collecting the labeled examples of prompts, response, kick off the fine-tuning job, I get an email telling me, hey, your model is ready, you can use it. That's it. So I don't need to go into the details of what fine-tuning technique is being used. I trust the service is using the right thing. And the proof for me is when I start using the model, right? So when I start using the model, I end up, most of the time, quite satisfied. If I'm not, I just add more labeled examples. And again, you can run this on your private cloud on private endpoints. All right, so custom LLM, I tried to convince you why they might be useful to do one, but it turns out for many applications, you need more than one custom LLM, and let me convince you why, right? So in order to do that, let me walk you through the common usage patterns for LLM. So the most simple usage pattern, obviously, is here's a prompt, here's the response, right? So prompt, ChatGPT response. Second most common pattern is to chain together a few LLMs, right? So here's some text, pass it to a first LLM to summarize it, pass that summary to a second LLM to improve the summary or copy edit the summary, right? So a pipeline. Another pattern that people sometimes do is this ensemble, right? So here's a prompt. I'll send it to multiple LLMs and then take those different answers and use another LLM to kind of aggregate and combine all those answers. It's very similar to machine learning, right? Now, a very common pattern is what I call the mixture of experts pattern. So in the mixture of experts pattern, you train very task-specific custom LLMs, right? So you fine-tune custom LLMs for a very specific task. But then you also have to train a classifier that routes a prompt to the right custom LLM, right? So, and the idea here is that it turns out that many applications, it's unreasonable to think that a single-shot LLM can handle all possible cases, right? So here's a real-world example from Anyscale. Anyscale Doctor is a coding assistant on their platform. So they've trained multiple custom LLMs and this routing model. So the end result is they have faster performance, more accurate, and cheaper, right? So using this mixture of experts approach. All right, so Jeff talked about RAG. So another trendy topic in the space is augmenting LLMs with external data. And so the basic idea here is, what if I can take my own domain-specific data and use that to enrich the answer or ground the answers coming out of the LLM? So at a high level, so the names being used for this type of approach is either grounded generation or, as Jeff mentioned, retrieval augmented generation. So at a high level, so this is very simplistic, right? So here's a simple taxonomy of RAG, retrieval augmented generation. On one axis, you have freshness, right? So is my data static or is it changing over time? And then on the other axis, you have kind of the data type. Am I mostly talking about unstructured text, or am I also going to use structured data, right? So truth be told, most teams in this space right now are mostly dealing with static data, and most of the data is unstructured. So let's keep that in mind as I walk you through RAG. So RAG is popular for a few reasons. So as I mentioned, it allows you to bring in your external data, bring your own data to work to augment a large language model. But that also implies that I can scale the amount of knowledge accessible to the LLM without retraining the model, right? So I simply augment the LLM with more data. And then the promise here is if I ground the answer of the LLM with my own data, then the LLM will have more context, so the answer will more likely be accurate. So then that reduces possibly the amount of hallucination. So hallucination is the technical term used here for making shit up, right? So how does RAG work? So step number one, I have to decide what data should I bring into the LLM model. Should I bring in customer support files, emails, reports, right? So Slack conversations. So what data are we going to use to augment the LLM? Second decision I have to make is, how do I extract that data out of that text, right? So if I'm talking about PDF files, so what PDF data extraction library should I use? So if you use Python, for example, in Python there's several PDF data extraction files, right? So which one of those should I use? So if I'm talking about web pages, how do I crawl those web pages? Or if they're scanned documents, God forbid, then we're talking about OCR, optical character recognition. Again, multiple libraries, right? So which one of those libraries should I use? Now, once I'm able to extract the text out of my data, how do I break up that text into more manageable pieces? So this is what people refer to as chunking, right? So do I chunk the text by sentence, by paragraphs, or do I do it every 50 characters, every 100 characters, and so on and so forth, right? And then finally, you have to take that chunked text and convert that into a mathematical representation. So in this case, embedding models take text, words or sentences or text, and turn them into mathematical vectors. And these vectors have a very nice property in that semantically similar sentences or words are represented by very similar vectors, right? So if a sentence is similar to another sentence in this vector space, they will be somewhat close by to each other. So a key thing to know about these embedding models is there's no singular embedding model. In fact, there's leaderboards of embedding models. So there's lots and lots of embedding models. So again, you have to decide which of these embedding models work best for my data. Which brings us to retrieval augmented generation, which at a high level is, I have a prompt, right? So I embed the prompt. And then I search my database where I put all of my embedded text, my embedded vectors. And then I come up with matches, right, so relevant data. So then now the relevant data, I can pass that to the large language model. So the large language model now has some grounding. That's why it's also called grounded generation, right? It's grounded in the relevant matches from the vector database. So I hope it's become clear as I describe retrieval augmented generation that it also requires experimentation. So sure, you can build RAG by just doing, the default for every setting. But if you want to build RAG and get the most out of your data, if you want to build it in a principled manner, you have to do experiments, right? So like I said, so what's the right chunking strategy? Should I do every 10 words, every 50 characters, and so on and so forth? Which embedding model should I use, right? So which PDF data extraction library should I use? So these are knobs that you have to play with in order to get the right setting for your data. And like I said, the magical thing about RAG is it works out of the box, but then are you getting the most out of your data is the question, right? So, and a big topic here is the information retrieval, search, and ranking, right? So that's a big topic. Which search algorithm, which ranking algorithm should I use? So the good news is that many people have been running these experiments. So I can give you a few empirically based recommendations that probably will work for your data, right? So obviously at a high level, the most important thing is your data, right? Because this is augmenting your LLM with data. So data quality is the most important ingredient. The other thing people have noticed is that metadata is helpful, right? So if you have metadata, that's helpful. So all of this, as Jeff hinted to, is an argument why Senzing will make a material difference to your retrieval augmented generation if you use it against your data. The other observation is that chunking seems to make a material difference. So if you look at this list of possible knobs you can turn, besides data, if you absolutely have no time, the only thing you can play with is only one other variable. I would play around with chunking, right? So should I chunk my data by 50 characters, 100 characters, so on and so forth, right? So much so that I think chunking is actually more impactful than picking the right embedding model. And I won't go through this, but there's also high-level recommendations about what to do about embedding models and retrieval and ranking. So let me tie this to the previous pattern around custom LLMs surrounding fine-tuning. So here's a pattern that I'm also starting to see more often, which is retrieval augmented generation with a custom fleet of large language models. So it's very similar to what we saw around fine-tuning. The idea here is if you can develop a classifier, a routing model that routes the prompt to the right LLM, even within the context of a RAG application, you benefit from a faster model, cheaper, and more accurate. All right, so we are still in the very early days of all of these applications, right? So, and truth be told, a lot of teams are probably still in the prototyping stage. Many teams are already playing around with retrieval augmented generation. But if you look under the covers, many of the applications that are being proposed or deployed are still quite basic, at least basic compared to the types of software applications we've gotten used to. So my analogy here is it's like building an entity resolution system, right? So building a RAG system is simple. You can do it over a weekend. Heck, these days you can probably build a ER system using an LLM, right? So, but if you look at a modern entity resolution system, there's a lot of features that you kind of take for granted. So to me, your generative AI apps, I mean, the end state would be something like Senzing, right? So what do I mean by that? So I want an app that is able to absorb data in real time and kind of produce responses within milliseconds. I also want an application that has all of the enterprise features that I need, right? So security, privacy, encryption. And then the other thing about Senzing that's quite cool is it's principle-based, right? So in that it can take in new data, and that new data is reflected in the application without any need for retraining or tuning, right? So long story short, I want my generative AI app to be like Senzing when it matures and grows up. So I'd be remiss not to talk about risks. The week after, there was a global AI summit at Bletchley Park in the UK, which brought all of the leaders in AI in London. So, and risk is top of mind for executives, right? So a recent MIT survey of executives actually showed that their number one concern is around generative AI is risk, and number 3 is understanding all of the different regulations that are floating out there. And it's hard, it's not hard to see why executives are so concerned about risk, right? So, because right now we have a smorgasbord of regulations. So in this slide, I have a very simple summary of the regulations that are already out there, and there are many more, right? So you have obviously the EU. Unbeknownst to many, China actually has a lot of regulations around AI. And the US is a mess, right? Because every state is going to regulate the way they want to. So yeah, so it's quite confusing. And it's that's why a lot of executives are panicked about where do we start. So I have 2 concrete suggestions for you. First, take a look at the National Institutes of Standards and Technology. They have a risk management framework for AI. So one thing you might consider is aligning your generative AI apps along with the NIST framework, right? So, and the NIST framework is very much emphasizes documentation, right? So documentation, I have another concrete suggestion. So if you were to mitigate risk right now, step number 1, improve your documentation. So one way to improve your documentation is take a look at the questions the Federal Trade Commission posed to OpenAI. There's 17 pages of questions, by the way, and I summarized it in this one slide. But take one of your generative AI apps and try to see how many of those questions you can answer. And that is step number 1 towards improving your documentation for AI. And my go-to resource here is luminos.law, the first law firm that focuses on AI and analytics. And they also help write the NIST AI risk management framework. All right, so let's summarize some of the key takeaways. First, get started, and get started now. These LLM apps, LLM models are amazing. Start with the proprietary models like OpenAI and Anthropic. But don't sleep on the open source LLMs. As I showed you, they're already kind of amazing. At least for specific tasks like summarization, they're right there with the best commercial models. So the thing about the open source models is you cannot pack your prompt the way you do for ChatGPT, right? So open source models work if you can break your prompt into more manageable pieces and then chain together a series of prompts to get to the end result, right? So open source large language models are amazing, but don't overcomplicate the prompt. Fine-tuning works if your task is very specific and you have the data for your specific task. Most LLM apps will require multiple custom LLMs connected using a routing model and a computational graph. Retrieval augmented generation works, as I showed you in this one study. 14% increase in productivity is enough to capture the attention of any executive. Building RAG applications in a principled manner requires experiments. So I shared some best practices, including chunking. So if there's only one thing you can do, play around with your chunking strategy. Data quality and metadata, super important for RAG applications. Sensing on your data will make a material difference on your RAG application. Self-hosting and fine-tuning, much harder than you think. Luckily, we have services like Anyscale that you can run even on your own private cloud using private endpoints. I talked about 2 ways that you can take these LLMs to the next level by customizing them. The first is using fine-tuning to come up with a custom LLM. The second is to augment your LLM using your own data via retrieval augmented generation. So in the future, we'll have services, in the near future, we'll have services where all you have to do is focus on labeled data, and the service will either come up with the most optimal RAG setup for you, or, so this is a bit of science fiction on my part at this point, but, or it'll come up with a computational graph with a series of fine-tuned LLMs. That's why I call it the new AutoML, right? So, deploying these models will get cheaper quickly. We're still in the early stages of optimizing these models. Very soon, we'll have these models running on small devices offline. And in the short term, pay attention to AMD hardware, because a lot of people are working on deploying, not training, just inference on AMD hardware. So within the next few months, AMD hardware will be competitive for inference. As far as mitigating risks, 2 concrete suggestions. First, document early, document thoroughly. Secondly, invest in tools for evaluating your generative AI applications. Finally, our North Star should be applications like Senzing that combine big data, real-time, and AI seamlessly. And that's it. So I'll be at the conference until noon. If you have questions, I'd love to chat. In the meantime, I have a newsletter and a podcast. So thank you.